Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to talk about how to find the asymptotes for a general rational function. So if we have a function that's in lowest terms, and that is important that the function is in lowest terms, we'll talk about how to find its vertical asymptotes and whatever other types of asymptotes it might have. For the vertical asymptote, all we have to do is find the zeros of the denominator. If we know that a value is a 0 in the denominator, then x equals that value is a vertical asymptote. So vertical asymptotes we'll look for first, find the zeros of the denominator. Again, assuming that the function's already in lowest terms, meaning its numerator and denominator don't have any factors in common. Now, for the graphs that we've seen so far had horizontal asymptotes, but that's not always true. If the degree of the numerator is less than the degree of the denominator, meaning that the largest exponent for x in the numerator is smaller than the one for the denominator, then y equals 0 is the horizontal asymptote. If they have the same degree, say we have an x cubed on the top and the bottom, then a over b is going to be the horizontal asymptote, where a and b are the leading coefficients of the numerator and denominator. So when the degree is lower on top, the horizontal asymptote is 0. When the degrees are the same, the horizontal asymptote we find by the leading coefficients. When the numerator is exactly, when its degree is exactly 1 higher than the denominator, like we have x cubed on the top but x squared on the bottom, then we have a slant asymptote or an oblique asymptote, and we'll find that by dividing. So we're going to look into all of these cases in these next 3 examples. First one, find all the asymptotes of f of x equals x minus 5 over x squared minus 3x minus 28. I'm going to rewrite the denominator in factored form, and that factors to be x minus 7 times x plus 4. And the zeros would then be x equals 7 or x equals negative 4 for the denominator. And that means that those two are both vertical asymptotes. So vertical asymptotes, x equals 7, x equals negative 4. Now, when we look at, when we're looking for the other type of asymptote, notice that the degree in the numerator is 1. The biggest power of x we have up there is x to the first, but in the denominator it's x squared. So the denominator has greater degree. That's the case where the horizontal asymptote ends up being y equals 0. Now, there's another way to do this that shows up a lot, and the idea is that we take the biggest degree term that we have anywhere, which is x squared, and we divide everything by x squared. So x over x squared minus 5 over x squared all over x squared minus 3x over x squared minus 28 over x squared. And we simplify this as best we can, and what we end up with is 1 over x minus 5 over x squared all over 1 minus 3 over x minus 28 over x squared. And the idea is the horizontal asymptote tells us what happens as x goes towards infinity. When x gets really big, all 4 of those terms head towards 0. And so what we really end up with is 0 over 1, which equals 0. So you can do it that way as well. But when we know that the degree in the denominator is greater, the horizontal asymptote is always going to be y equals 0. Let's try a second one. F of x equals 6x to the 4th over 2x cubed. Again, I'm going to start with the vertical asymptotes. And since everything is as factors as it can be, I'm going to set 2x plus 3 equal to 0 and solve. my vertical asymptote here will be at x equals -3/2. Now, in the numerator, we have a degree of 1. In the denominator, we have a degree of 1. Those are the same. And when that's the case, we divide the leading coefficients to find the horizontal asymptote. The horizontal asymptote here would be y equals 6 divided by 2. 6 divided by 2. And 6 divided by 2 is 3. So there's going to be a horizontal asymptote at y equals 3. Now again, if we divide through by x, this function turns into 6 minus 4 over x over 2 plus 3 over x. And those two terms go to 0. So what we have is the fraction 6 over 2. That's why we divide them. Right. The last one's going to have the other type of asymptote. But before we worry about that, try to be patterned about it. And so I suggest you look for the vertical asymptotes first. And the vertical asymptote this time comes from the denominator being set equal to 0. X equals -3 is the vertical asymptote. Now for the horizontal asymptote, notice that the degree of the numerator is 2, but the denominator is only 1. And so this is going to have a slant asymptote because it's 1 higher in the numerator than the denominator. And to find that, we want to divide x plus 3 into 2x squared minus 8x minus 10. Now I can do this with synthetic division. So -3 in the box, 2, -8, -10. Bring down the 2. -3 times 2 is -6. Total the column, -14. 3 times -14 is 42. Total the column, and we get 32. So this quotient is 2x minus 14 plus 32 over x plus 3. And when x heads towards infinity, y equals 2x minus 14. That is your slant or oblique asymptote. So a good strategy is first start with the denominator. Well, actually first make sure everything is in lowest terms, and we'll do some in a later video where that's not the case. Then start with the denominator, find your vertical asymptotes at the zeros of the denominator. Then compare the degrees in your numerator to denominator. If the degree in the numerator is smaller, the horizontal asymptote is y equals 0. If the degrees are the same, divide the leading coefficients, y equals that number is your horizontal asymptote. And if the degree is higher in the numerator, like this last example, divide to find that slant asymptote. All right, see you in the next one.